Hello friends, in the previous session we discussed about the shortest job first non-preemptive version. In this particular video session we are going to start with its preemptive versions working. So let's start with its working. We have the same example mentioned over here so that we can finally compare the differences in various measures that we computed in the last video. In case you didn't view it, please view it once by moving on to the previous videos in the same playlist. And we have the preemptive SJF version over here. So first of all, what does a preemptive SJF means? The preemptive means that if I feel that there is some benefit in stopping a particular process for some small time interval of time and giving the CPU to some other process and then restarting this process later, then if I feel that there is some benefit, then I would make the decision of doing that. And how do I decide that there is some benefit? Over here we decide by seeing that if there arrives a job with a shorter burst time, with a smaller burst time, with a smaller execution time, then we would stop the current executing task and give the CPU to the smaller burst time job that has just arrived, and once it completes, then we would continue the working of this particular job that we stopped. So that is the decision that we take, that is the criteria over which we decide to stop a particular process or not. And this is what we mean from preemptive shortest job first. It is also referred to as shortest remaining time first in many questions and in many textbooks. So please note down that shortest remaining time first is a synonym to preemptive SJF. And now let's start with the working of this. So in the example that we have three processes over here with three different arrival times. As we can see that P1 is the only process which arrives at time instant 0, and then the other processes arrive, P2 and P3, with different burst times are also listed over here. So we start with which process? We obviously start with P1 because it is the only available process with us at time instant 0. So we start with its execution till no other process arrives. We just continue its execution. Since we know that P2 only arrives at time instant 1, so at time instant 1 we would check whether we should preempt this process or not. So at time instant 1, what we consider is we check that P2 has a smaller burst time, right? P2 has a smaller burst time. Why? Because P1 has already executed, and what is the time left? Time left over here after 1 instant is 4. So P1 has 4 time units to be executed and P2 has only 1 time instant to be executed. So clearly P2 should be executed next, right? So we start the execution of P2. Again after 1 time instant P3 arrives, right? But P2 completes its work at time instant 2, so there is no decision that we need to make with P2 because P2 just completes, so it is out of picture now. So we are done with this. So I'm just putting a cross over here. Now at this time instant 2, we need to make a decision between P1 and P3, right? Because now there are two processes over here in picture. So P3 has time units of 2 to be executed and P1 has time units left, which is 4, right? Which is 4, yes. So obviously now P3 has a smaller time interval to be executed. So we start with P3 over here. We execute now after 1 time instant. If I say after 1 time instant, it is very clear that P3 will have only 1 time unit left and this is going to be reduced, right? And P1, since it is not executing, so it is going to remain same. So after we complete P3 only, we are going to start with the execution of P1. So once P3 completes, after 2 seconds, that will be 4 over here, the P1 executes to complete its remaining work of 4 seconds and it completes at time instant 8. So that's all for this Gantt chart, and now we are going to compute the various measures. So first of all, we have average turnaround time. So I would define it again, but we have already discussed it in previous sessions, but in case you have not seen them, I'm just defining it in brief over here. You may want to to view the previous videos, you can. So first of all, if we say about average turnaround time, so it is the sum of the turnaround times of all the processes divided by the total number of processes. Right. Now what is the turnaround time of a process? The turnaround time of a process is the difference of the time instant at which a process completes minus the time arrival time of that process. For example, if I say P1 completes at 8, right? And what is its arrival time? Its arrival time is 0. So its turnaround time would be 8 minus 0. So that is what I've written over here. Similarly, for P2, it would be 2 minus 1. So 2 minus 1. P3 completes at 4. So 4 minus 2. So if we simplify this, we get to know that it is 3.67. Similarly, if we find the average waiting time, it is again the sum of the waiting times of all processes divided by the number of processes. And what is the waiting time? Waiting time is the time difference between the if we say the time, first of all, how do we define it? It is defined as the total time for which a process waited in the ready queue, right? So we would just keep it simple like that, and we'll see, because the definition basically, this definition keeps remains same throughout, but the other things vary. Like if I say that it is the difference of the time for which, first of all, it is given the CPU minus the arrival time, it would differ, right? So let's see how it differs. Let's see what is average waiting time over here. First of all, we have the Gantt chart over here, right? So if I view the Gantt chart, we come to know that P1 waited for 4 minus 1. This is the entire thing it waited for. P1 was not in picture over here. So 4 minus 1, which is 3 seconds. P1 waited for 3 seconds over here. And since it arrived at 0 instant only, so we do not need to subtract the arrival time from here. So we would say the waiting time over here for P1 is 4 minus 1. Plus for P2, now let's see for P2. For P2, if I see that, I can say that P2 waited for 1 second, right? But if I see that its arrival time, it is 1. So the simplest thing is just compute its waiting time from the Gantt chart and then subtract its arrival time from it. So waiting time from Gantt chart is 1 minus its arrival time 1. So waiting time for P2 is 0, right? Similarly for P3, waiting time from Gantt chart is 2. It was not executing over here, minus its arrival time 2, we get to know that its waiting time is also 0. So the average waiting time comes out to be 1, which is very much less than the previous. We are going to compare the measures at the end, and then finally the average response time. So the average response time was the sum of the response times of all the processes divided by the number of processes, which is 3 in this case. And what was the response time? The response time was the time instant at which you got the first response from a particular process, right? So for P1, if I say I see from the Gantt chart, I got the response at time instant 0 and its arrival time is also 0, so the response time is 0. Then for P2, if we see the response time, the first time at which we got the response was 1 minus the arrival time, which is 1, so the response time is 0. Similarly for P3, it is 2 minus its arrival time 2, which is also 0. So the response time over here is 0 plus 0 plus 0 divided by 3. The average response time comes out to be 0, which is a very good measure in this case. Now if I compare the values with the non-preemptive version, so what would I see is, if I compare the values, the average turnaround time that we got in the previous session was 5.33. In this session, in the preemptive version, it is 3.67. The average waiting time was 2.67. Over here, it is 1. So average response time was 2.67. Over here it is 0. So what we mentioned was the measures would differ, and they do differ in the preemptive versions of an algorithm. So that's all for the discussion on shortest job first over here, and we'll be continuing with some more algorithms in the next session. So stay tuned for more good work coming up. Thank you.